Dear students, in the previous video lecture of mole concept, at the end I talked about mass, moles, number, conversion chart. Here also you can see the chart is here. In many questions, they give you mass of the substance. They may give you volume of the gas at STP, and they may ask number of atoms. So what will you do? You can see in the chart, if the mass of the substance given, mass must be in gram. That mass first you convert into moles. How? By dividing with molar mass. And moles can be converted into molecules by multiplying Avogadro number 6.022 into 10 raised to 23 if the basic unit of the substance is molecule. And then molecules can be converted into atoms by multiplying atoms present in one molecule. And in the reverse way, if you go, molecules can be converted into moles by dividing with this Avogadro number, and moles can be converted into mass by multiplying the molar mass. And here you see, number of atoms can be converted into number of molecules by dividing with atoms in one molecule. Okay, now volume of the gas at STP is given. You can get the number of moles by dividing volume of the gas at STP with 22.7. That volume must be in liters. Same way, moles can be converted into volume by multiplying 22.7 liters. In this video lecture, I will discuss the questions of exercise 1. These are the questions of exercise 1. These questions can be solved easily using the chart. The first question says, what is the mass of one molecule of CO2? To solve these types of questions, first you find molecular mass. If I find molecular mass of CO2, it is summation of atomic masses. 12 is the atomic mass of carbon plus 16 is the atomic mass of oxygen. 2 oxygen atoms are this, so I will multiply 2. This way I get 44. So this means CO2 is 44 times heavier than 1/12 mass of carbon 12 isotope, and that is 1 AMU. So I can write mass of one molecule as 44 AMU, and the relation between AMU and gram is 1 AMU is 1.66 into 10 raised to minus 24 gram. And if you solve this, the value comes as 7.304 into 10 raised to minus 23 grams. One more way to solve this question is, the molecular mass is 44. I can write molar mass. Molar mass of CO2 as 44 grams. Molar mass is mass of 1 mole. Means how many molecules? Na. That is 6.022 into 10 raised to 23. So these many molecules have got mass 44 gram. So what will be mass of one molecule? Mass of one molecule I can write as 44 upon Na, or 44 upon 6.022 into 10 raised to 23. If you solve, the value will come 7.304 into 10 raised to minus 23 grams. The second question says, what is the total number of atoms in 4.9 grams of H2SO4? Now to solve these types of questions where mass of H2SO4 given and number of atoms have been asked, to solve these types of questions, I'll take the help of the chart. Mass of the substance is given. How much? 4.9 gram. Now first I'll find number of moles. The number of moles will be 4.9 upon the molar mass of H2SO4 is 2 plus 32 plus 64, and that comes as 98, and the value this comes as 0.05. So once you get number of moles, with the help of number of moles you can get number of molecules. Number of molecules, what will you do? Moles into Avogadro number. So 0.05 into 6.022 into 10 raised to 23, and the value will come as 3.011 into 10 raised to 22. Now these are the number of molecules. One molecule of H2SO4 has got how many atoms? 2 hydrogen, 1 sulfur and 4 oxygen. So total 7 oxygen atoms are there. So number of atoms will be 7 into 3.011 into 10 raised to 22. Now if you solve this, the value will come as 2.177 into 10 raised to 23. So this is the number of atoms present in 4.9 grams of H2SO4. Now the third question. Here the question says, what is the number of oxygen atoms present in 4.9 grams of H2SO4? The question is very similar to the previous question. The only difference is in that question it was asked total number of atoms, while here we have to find number of oxygen atoms only. So again I'll use the chart to find the answer. H2SO4 mass is 4.9 gram. So first of all I'll convert mass into moles. The mole is the central part. So again I'll get the same data, 4.9 upon 98, that is molar mass of H2SO4. The value comes as 0.05. And once I get the moles, I'll find the molecules by multiplying moles with Avogadro number 6.022 into 10 raised to 23. And the value comes as 3.011 into 10 raised to 22. Now, what is the difference? In the previous question, I multiplied 7 in this number of molecules to get total number of atoms, while here we have to find oxygen atoms, so I'll multiply this 4 only. So the number of oxygen atoms will be, O atoms will be 4 into 3.011 into 10 raised to 22. And the value comes as 1.2044 into 10 raised to 23. So this is the number of oxygen atoms present in 4.9 grams of H2SO4. Okay, now I'll take another question here. Now the fourth question says, what is the volume occupied by 2.2 grams of CO2 at STP? In the question, mass is given, mass of CO2 gas, and volume at STP is asked. So again I can use the chart to solve this question. In the question, mass of CO2 given. So basically 2.2 grams CO2 given, and question says find the volume occupied by the gas. So we have to find volume of the gas at STP. So central part is number of moles. First I'll find the number of moles. So number of moles of the substance will be 2.2, that is mass upon molar mass is 12 plus 16 into 2, that is 44. So 2.2 upon 44, the value comes as 0.05. Once you know number of moles can be converted into volume of the gas at STP. How? By multiplying 22.7. So this way, volume at STP comes as 0.05 into 22.7. And if you solve this, the value comes as 1.135 liters. 1.135 liters. Now I'll take another question here. This question says, what is the number of molecules present in 1.135 ml of NH3 at STP? This time volume at STP given and number of molecules is asked. So again I can use the chart to solve this problem. This time volume of gas at STP is given. How much is the volume? 1.135 ml. And they have asked number of molecules. So the central part is number of moles. First I'll find the number of moles. The number of moles can be found by using formula volume of gas at STP upon 22.7. But take care of this unit. Here it is ml, while the unit here must be liter. So I'll multiply 10 raised to minus 3. So this is what? Number of moles. Now how will you convert number of moles into number of molecules? By multiplying the Avogadro number. So 10 raised to minus 3 here upon 22.7 into 6.022 into 10 raised to 23. And if you solve this, the value comes as 3.011 into 10 raised to 19. So with the help of this chart, we can easily convert volume of gas at STP into number of molecules. Now I'll take another question here. This question says, what is the number of atoms present in 1 centimeter cube of CO2 at STP? The question is very similar to the previous question. Here volume is given at STP and question is find number of atoms. While in the previous question, volume at STP was given and the question was find number of molecules. Again, we can use the chart to solve this question. Here the gas CO2 volume is given as 1 centimeter cube. As we know, centimeter cube and ml are same, so I can write this as 1 ml. Take care of the unit, 1 ml. And while using the formula, here you can see the volume must be in liter. So to get number of atoms, first you have to find number of moles. How will you find number of moles? 1 into 10 raised to minus 3, that will be the volume of the gas in liters upon 22.7. Now, once you get number of moles, you can get number of molecules by multiplying this Avogadro number. So, the molecules will be 1 into 10 raised to minus 3 upon 22.7 into 6.022 into 10 raised to 23. So, number of molecules. Now, number of atoms. What will you do? Molecules will be multiplied with atoms in one molecule. How many atoms are there in one molecule? 1 carbon, 2 oxygen means 3. So, you have to multiply this with 3. So, the number of atoms will be 3 into 10 raised to minus 3 upon 22.7 into 6.022 into 10 raised to 23. Now if you solve this, the value comes about 7.958 into 10 raised to 19. So number of atoms in 1 centimeter cube of CO2 at STP. Now I'll take another question here. This question says, what is the number of molecules present in 9 centimeter cube of water? Now students, please take care of this. This is not the volume of the gas at STP. This is simply the volume of liquid where density of the liquid is given. So what will you do? Just get the mass. Just get the mass by using formula volume into density. 9 into 1, and that comes as 9 gram. Now once you know mass, you can easily get the number of molecules using chart. Now you attempt this question on your own. You can mail me your answer. Now I'll take another question here. Here the question says, from 6.8 milligram of NH3, 10 raised to 20 molecules are removed. How many gram molecules are left? So if I consider 6.8 milligram of NH3, from here we have removed 10 raised to 20 molecules. And question is, how many gram molecules are left? Please note, gram molecules means question says how many moles left. So what will you do? Units are different. To solve these types of questions, just convert all into one unit. So since the question says find the number of moles left, I'll convert this mass into moles, I'll convert molecules into moles, and then I will subtract to get number of moles left. So the moles in the container is 6.8. Since the mass is in milligram, I will multiply 10 raised to minus 3 to get gram upon 17. That is the molar mass of NH3, and the value comes 4 into 10 raised to minus 4. These many moles are there, and I have removed 10 raised to 20 molecules. So how many moles have been removed? 10 raised to 20. Use the chart, divide this with Avogadro number, and this comes as 1.66 into 10 raised to minus 4. These many moles were there, these many moles you have removed. So how many moles left? Just subtract 4 into 10 raised to minus 4 minus 1.66 into 10 raised to minus 4. Take 10 raised to minus 4 common and you get 2.34. So these many moles left. Now I'll take another question here. Here the question says 454 ml of water vapors at STP are condensed to liquid state. If the density of water is 1 gram per ml, then find the volume occupied by water. What is given? The vapor, and how much volume is given? 454 ml. This is condensed to liquid, and they have asked the volume occupied by the liquid. As we know, volume is not a definite property for the gas. So if you condense, the volume will change, volume will decrease. What is the definite property for both? Mass. Mass, whether it is water or it is vapor, both mass will be same. So here our job is to convert this volume which is given at STP into mass, and that mass will be converted into volume with the help of density of water. So how will you convert this volume at STP into mass? First you convert this into moles. How will you convert this into moles? This volume should be divided with 22.7, and this way the value comes about 0.02. So once you know moles, you can easily get mass of the water, and that is 0.02 into 18, which is molar mass of H2O, and the value comes as 0.36 gram. Since the density is given as 1 gram per ml, the volume of this H2O liquid will be 0.36 ml. So when 454 ml of water vapors at STP are condensed to liquid, the volume will change into 0.36 ml. Point is clear? Now I'll take another question here. Here the question says 3.4 gram of NS3 and 2.27 liters of H2 at STP are mixed in a container. What is the total number of molecules present in the container? I think you should solve this question on your own. You can convert mass into moles, volume at STP into moles, and then total number of moles will help you in finding the total number of molecules. You can share your answer with me in the next video lecture. I will discuss the concept of average atomic mass and average molecular mass. Thank you.